So I'm Helen Hooker. As Daniel already mentioned, I'm here from the University of Reading, the Department of Meteorology. I'm currently a PhD student there in my final year, and previously I used to work for the Met Office as a weather forecaster. So the current weather forecasts are nothing to do with me, as Daniel already mentioned. And then I've also worked in education more recently, and also looking at data analysis within an education environment. But I wanted to kind of get back to science. So for the last 2 years or so, I've been researching improving flood predictions using satellite data. So I'll come on to that a bit more throughout the talk. So today I'm going to talk a little bit about our climate, which includes the climate in the UK and also globally. And I'm going to look a little bit about the past year, because a lot of the statistics have just been released. You've probably seen in the news. So I'm going to talk a bit about our current climate and flooding in the UK and how it might change in the future. And also how we can use kind of novel data sources like satellite data to improve flood prediction. I'm going to cover 4 types of flooding, mainly related to flooding in the UK, because there are different types. How our warmer climate is impacting flooding. A look at 2022. I'm going to talk about disaster risk reduction, and this is looking at more from a global perspective. Flood forecasting systems, what they are and what they can do. I'm going to talk about how we can use satellites to observe flooding from space, and then how we can use that data to evaluate the forecasts of flooding and improve them, hopefully. Okay. So the main 4 types, I think as we're very close to a river here, I'll start with the one on the bottom left. So probably if you think of flooding in the UK, you would probably think of a river, heavy rainfall upstream, moving across the land or under the ground into the river levels rising, overtopping the river banks, and then water spreading onto the floodplain. So that's your typical river flooding or fluvial flooding. Probably this, I don't know which is the most common. I'll move on to, so fluvial flooding you typically see, particularly around now, winter time, and also during the spring. And then summer months, you're more likely to see pluvial flooding or surface water flooding from heavy showers. So heavy, thundery summer downpours falling onto hard surfaces, particularly in urban areas, so in city centres where you've got an impermeable surface. The water will pool. If it's very intense rainfall, will quickly lead to flooding, and it will also run off, potentially run off into rivers, but also run off and cause problems with, for example, the underground network in London, as we saw in 2021. Another type of flooding, coastal flooding, you'll get this where you have perhaps spring tides, so a high tide combined with a storm. So you'll have a storm surge where you'll have a kind of a wave effect from the sea that moves inland. And then 4th type, groundwater flooding. This is where the groundwater level, usually below ground, you perhaps wouldn't even know it was there during heavy rainfall like we've had for the last, I don't know, 5-6 weeks. The groundwater level can rise above the ground, contributing to flooding. And I've described all of these as though they're individual events, they're individual causes of flooding. They can be, but they can also combine together. So we can get a combination of these as well. And there are other flooding types that I've not mentioned here that impact other countries more than they impact us, which I'll mention some of those later. Okay, I'm just going to give you a couple of examples of flooding events in recent years. So this is a picture postcard Cornwall on a typical summer's day. This was July 2017, and you can see that this is Coverack, which is down here on the Lizard, quite steep sloping land down to the sea, down to the beach. There's two very small streams in Coverack. It's a very small catchment, just 2 kilometres squared. And on this day, okay, so you've probably seen images like this on the weather. This is rainfall radar. So on this day, there was a forecast of showers, and I think there was like a low-level warning of potentially causing some flooding somewhere in Devon or Cornwall, without any specific locations named. So this shower here developing in the channel, it's already very active. So you can see the brighter the colours, the more intense the rainfall is. So this is at 12 o'clock, and the shower moved inland. So now we're at 1 o'clock, and you can see it's over Coverack from 1 o'clock, well, right through until about 5 o'clock. So during that time, it's quite tiny, I know, but there's some whites in there in this kind of supercell rainfall, and it just stayed in the same place. So this brought very heavy rainfall to one very specific location. Now we record rainfall in rain gauges on the ground, and the nearest one to Coverack actually was about 8 kilometres away, and this didn't record any rainfall. So it's extremely localized. So we can actually calculate how much rainfall fell and accumulated by using these radar images. And it was estimated that up to 200 millimeters fell in about 3 hours. And to put that into kind of context, during Storm Alex, the new 2-day rainfall record was around 86 millimeters, but that was over kind of a 48-hour period. And this occurred in just 3 hours. So it actually brought about 500,000 meter cubed of water. So what was the impact of that? Okay, so first of all, what was it like? So my parents are in the audience, and my dad actually took these videos because they lived in Coverack at the time of this event. So this was this shows the extremely heavy rainfall, but I don't know if you can see, there's kind of large hail about this size, kind of golf ball size. And that caused quite a lot of damage to greenhouses and conservatories in the area. And then I'm just going to go back. Okay, so this is a garden on the top of the hill. There's a very small trickle of a brook running through here, and this is a garden path. This video, this is very shortly after the storm. Okay, so this is now the river, or the trickle, and this is the garden path. And then I stole this one from The Guardian. I'm going to just go past the rescue. Okay, so, oh gosh, they're all going. Sorry. Okay, I'm just going to pause that one because it goes really quickly. So these were those 2 small streams. And yeah, it was just unbelievable. I was kind of following it on the news. And this footage kind of was, I think it wasn't just the fact that the streams had overflowed. The main road in Coverack basically become this torrent of water. We'll keep playing. So I forgot to say, so this is an example of surface water flooding that I mentioned earlier. So you can see it outside now, but the rainwater very quickly pooling and puddling and flooding impermeable surfaces. Okay. They're all going to play. Okay. So the impacts, probably the main impact was, well, damage to properties and vehicles, but also the damage to the road. Coverack has one road that goes down into the beachfront and the town. So that was badly damaged, and the car park was also badly damaged. And this was in July, so it was peak visitor season, so that had to be closed for a period of time. This is actually the main road during the flood. I need to probably move on.
Yes.
So different type of, I haven't got pictures here. I had a lot of pictures, but I didn't put any in for this one. So this was February 2020, so 3 years ago now, nearly. And at the time, this was quite unusual to have 3 named storms in 1 month. So we had Kira, Dennis, and Jorge that kind of swept across the country, very, very strong jet stream, more radar. You can see they brought an exceptional amount of rainfall, and actually it was the wettest February ever recorded in the UK. On this is the rainfall amount here, and the red squiggly line is kind of the typical maximum rainfall that you would see over a kind of an average over a longer number of years, so between 81 and 2010. And then the blue bars show the rainfall in 2020. So I've labelled Kira and Dennis and Jorge. And actually it was the main issue with this was the fact that Dennis came so quickly after Kira. So Kira kind of saturated the ground and the soils, raised the water table. So the groundwater levels were quite near the surface in many places already. And then Dennis came very soon after, which caused water levels to rise very, very quickly, and they reached their highest ever kind of level. This is for the River Wye in Herefordshire. So this is actually showing the river level now. And you can see the peak here. So this would have been the Kira river water level rising, and then again for Dennis, where it, as I said, it reached its highest ever level. So this is a fluvial flooding event. This is the type of flooding we're experiencing now. So there's quite a lot of flood warnings at the moment because, again, we've had a spell of kind of 5-6 weeks of wet weather. So river levels are exceptionally high again, and we're coming towards that January, February time of year where we'll see these sorts of flooding events. Okay, who's seen these before? Okay, good. All right, so these are climate stripes. So these were developed by Ed Hawkins, Professor Ed Hawkins from the University of Reading. And each of these lines represents the global temperature within 1 year. So on the left, we're starting at around 1900, and then moving through time up to, I haven't got 2022 on here, so this goes up to 2021. So this is the average global temperature observed from the 1900s up to a year ago. So the darker the colours, the bluer colours, the cooler the temperature was, and then the darker the redder colours are, the darker the shades of red, the warmer the temperature is. And you can actually search up a location anywhere in a country anywhere in the globe yourself. So if you go on to show your stripes, you could pick a country and look at the warming stripes for a particular place. They all go from blue to red. So the temperature has increased around the whole globe. This is showing the average for the globe. So we're now at about 1.2 degrees warmer than we were kind of pre-industrial time. So I did this for somewhere nearby. So these are the warming stripes for Oxford. You can see there's more variability because it's more of a localized measurement, but it's the same trend from cooler in the past to warmer now.
Can I ask a question?
Yeah, sure.
The very broad, dark bands there,
Yeah.
would that be the winter of 62, 63?
This one?
No, the one to the left of it, to the left. Or would that be 62, 63?
I think this is about 2000 here. Oh, hang on, let's go on to, if I go on to this one, then we've got dates.
Oh, yeah.
These two, yeah.
They're just trying to get into context.
Yeah, you're right. So if you prefer scale axes, this is another way of visualizing. Now, I forgot to say, these are very, this I don't know what you think about this visualization of climate change, but it's had a lot of impact, particularly around Reading. So if you were to visit Reading to go shopping, and you got on a bus, so I don't know how many of the buses, but the buses are now painted with the climate stripes. They're also being used for, I'm not sure of the team, but it's the Reading Football Club. Is it Reading United? Maybe. Their kit is now the climate stripes. So it's kind of taken over Reading. And if you saw any of the news coverage from COP26, which was held in Glasgow the year before last, these were kind of a big feature of COP26. So I guess they're kind of a logo. They've become a logo of climate change. So this is another way of interpreting them. So this is now showing a temperature anomaly, which means it's the difference from the average. So 0 would have been the average temperature across. This would be from 71 to 2000. So below the line is cooler, above the line is warmer. So Oxford in the past few years, on average, has been about 1.5 degrees warmer than was typically average. And then just to show you another one, this is Svalbard, which is in Norway. Well, it's a Norway island, but it's actually in the Arctic. So we're going right up into the Arctic. So actually warming isn't the same everywhere across the globe. It varies. And the Arctic is warming 4 times faster than anywhere else. So the temperature here in Svalbard is now around 4 degrees warmer than pre-industrial times, or even not pre-industrial, but warmer than 71 to 2000. Okay, so to show that on the map, this is just looking at 2022. So I'm kind of coming on now to look at last year's, I guess, temperatures and the records that were broken as well. So reds are warmer than average, blues are cooler. So if you look at the land areas, you'll mainly see reds, and you'll see darker reds kind of across Europe, where we experienced extreme drought last year, and then up across the Arctic regions. And this was kind of despite it being a La Nina year, which you may have heard about. So La Nina is a cooling of the tropical Pacific Ocean in this region. And actually, unusually, we've had this for the last 3 years. So for 3 years in a row, we've had a La Nina effect, which actually generally keeps the globe cooler. But even with this effect, this 2022 is still the kind of the 5th warmest year on record, and the last 8 years are the 8th warmest on record. So I just wanted you to remember this. Okay, I'm going to move on. Okay, so this is still looking at 2022, but now we're looking at precipitation instead of temperature. It's still relative to an average. So greens are wetter and the brown colours are drier. So generally, with a warming climate, the atmosphere can hold more moisture. So for every degree warmer that we are, the atmosphere can hold 7% more water. So we expect there to be more precipitation, more intense rainfall, more frequent rainfall events typically, but this won't be true everywhere, because with increased temperatures, you'll also see increased evaporation, dry soils, drought conditions. And really, I just wanted to highlight that the effects on precipitation is more variable. So you can see the drought we had over Europe and kind of the very wet monsoon rainfalls over Pakistan and India. Okay. This confused me a little bit, so I won't look at this for too long. But so all you need to look at is this bit in the blue box. So an increased amount of precipitation doesn't necessarily mean flooding will get worse. It doesn't automatically follow in every location, because it would depend on the state of the ground conditions as to whether that rainfall will then contribute to, say, river flooding, for example. But they've now, in a recent report that was produced last year for COP27, they've started to look at the impacts of flooding on different locations around the world, and whether and how confident they are that those impacts are caused by climate change. So the darker the blue on these negatives, then there's higher confidence that the inland flooding and damages were caused by, attributed to climate change. So you can see for the globe as a whole, there's high confidence, but elsewhere it's more variable in terms of the level of confidence. And so, for example, for Europe, there's medium confidence, whereas for the Mediterranean regions, which are more likely to see more of a drought impact, there's lower confidence, and there may actually be some positive impacts there. Okay, back to the UK briefly. So I think when I prepared my slides, it wasn't kind of confirmed that 2022 was the hottest ever for the UK, and then the Met Office and the BBC kind of beat me to it. So you may have seen this in the news already, that for the first time ever, our temperature last year on average for the UK exceeded 10 degrees. So this is the UK temperature squiggle since the 1900s. So we're right up here now. The red blobs are the hottest 10 years that we've recorded, and the blue blobs are the coldest 10 years that we've recorded. So you can see most of these have been, I think all of them have been since the 2000s, and then the majority of these are before 1920. But there were lots of records last. I like records and numbers, so sorry. I might go on a bit. So the warmest, it started on the first day of the year with the warmest New Year's Day recorded ever on record in London with 16.3. And then you probably remember melting in the summer, very, very dry. You probably remember your grass being, well, my grass was brown for about a month, and that we had barely no rainfall in the southeast for the whole of July. So it was a drought summer. Only 2 summers had been drier, and those were 76 and 95, and they were only marginally drier. So we were very close to breaking the record there. Hottest day of the year, the temperature exceeded the previous record in many, many places across England, that there were records in Northern Ireland as well. So 40.3, first time over 40 degrees, and beat the previous record by 1.6 degrees. And then earlier I was talking about the 3 named storms in a month. Well, last year we had 3 in a week. I can't remember their names. Franklin was one of them. and it was very, very windy. So I think we had a gust record as well during one of those. Okay, so what about the future? I've mentioned this already, that warm air holds more water. In the UK, it's kind of a mix as to whether flooding will get worse where you live. So if you live in the west or the northwest, you're likely to see an increase in the frequency and the severity of flooding, particularly in winter, so around this time of year. And we're kind of seeing that now with storm after storm, bringing increasing amounts of rainfall and rainfall accumulations. And in those regions, they're projected to become up to 40% worse by the end of the century. In contrast to that, the southeast will be more susceptible to summer droughts. But what we tend to see is, we saw this actually last year as well, is following a very long dry spell, we'll get the break of the high pressure, and then there'll be exceptionally heavy showers and thunderstorms, and that brings you the surface water flooding risk. So longer prolonged dry spells, but then with a risk of the surface water flooding increasing following those dry spells. And it's easier to kind of follow in events. So you may well remember the Thames flooding in 2013 and 14. We can then look at those events and see whether they were more likely in the current climate than they would have been previously. So in terms of saying, is the flooding caused by climate change, it's easier to do on individual events. It can be easier. Okay, so I'm just going to talk a bit more globally about, this comes under disaster risk reduction, so flooding being one of several natural hazards that we see globally. Others would include drought, wildfires, earthquakes, volcanic eruptions. There are others, I've probably forgotten them, but mainly I'm focusing on flooding. So the UNDRR in 2015 produced the Sendai framework for disaster risk reduction. And this was a framework aimed at reducing deaths caused by natural disasters, the number of people affected by them globally, the loss due to economic losses from the events, and then the damage to infrastructure. So the aim of the framework is to reduce these losses. At the same time, and to accomplish that, we need to increase the amount of warning you get for hazardous events. So in the UK, we have quite good warning systems. Well, I say quite good, very good warning systems. So there are flood warnings issued at the moment. If there's going to be heavy rain or strong winds or snow, we'll see the warnings on the BBC telling us what action to take. Many countries don't have any warning system in place. And this actually is still the case now, even though this has been in place since 2015. So a more recent development is to make sure that everywhere is covered by early warning systems. And I've just kind of, sorry, it's a bit wordy. So just explain what an early warning system is, and that it's forecasting and predicting the event before it happens, but also an important part of that is then communicating the impacts of the event to the communities that are going to be affected, which is probably actually the more difficult part than the prediction in many cases. And this would lead to this idea of disaster risk reduction. You're reducing the risk from the hazard. So what tools are out there that can do this? So for flooding, anyone can go and look at this. This was developed by the Copernicus program, which is an EU program. If you search up GLOFAS, you will find a map of the world. And on this map, all major rivers are covered by a forecasting system. So it will tell you over the next 30 days where in the world is likely to flood. And it's freely available, so it can be accessed anywhere. What it does is it uses, you may have heard of the ECMWF weather forecasting model. It's the European medium range weather forecasting model. It's very good. It uses an ensemble approach, which means, so for example, the Met Office weather model generally for the globe would have been you would run the model once and that would be your forecast. The ECMWF model, they run it lots of times, 51 times, so you can get an idea of the probability of a bit. Say if you're looking at rainfall, it could tell you the probability of that rainfall event, which is useful for flooding because flooding is quite uncertain. So if you can attach a probability to it, it can give more useful information. So you start with the weather model, and then so you have your prediction of the weather, and then they link this to a hydrological model. So you take the rainfall outputs of the weather model and you put them into a river model, effectively, to get the flow. So the river discharge would be your final output. So this is a map, not very clear, sorry, this is Bangladesh. Each of these triangles are along the Brahmaputra River. And the colours tell you the flood risk. So you can see these are red. We saw one of these earlier. This is the river flow over time. So you could see, so say today was the 18th, you would be able to look at this and say, okay, so by the 22nd, 4 days time, I'm expecting my river to be at a flood level. So this is above a 5-year return period threshold is kind of a flood level for this region. So I'm expecting the floods to start in about 4 days time. And then that information can be used to mitigate against the risk of flooding, evacuate people, bring in supplies, communicate to people. So this is a flood awareness system. Okay, so this part, GLOFAS, is now here. So we're now going to combine this system with impact maps. So you've got your flooding map where you think the flooding is going to occur, and then you can overlay that with a map of impacts, which might be a map of population. So it might be a population map showing where people live. And then based on that, you can actually use this to trigger a financing agreement. So this is known as forecast-based financing. So it means that ahead of the event, you can actually release funds to humanitarian agencies like the START Network, who then work with local communities to distribute funding based on a computer model forecast. And this is really important for flood mitigation and preparedness ahead of the event. Okay. So this is kind of now more closely related to the research that I'm doing currently. So in countries such as Pakistan, the Congo, Brazil, it can be really hard to know where flooding is occurring, because we have quite a good network here of gauging stations, so measuring the river flow and or the river level. But around the world, there may not be as good coverage. So a way around that is to use satellite data to observe the flooding extent. This is a Sentinel-1 satellite from ESA, the European Space Agency, and on this satellite is a SAR sensor, which is synthetic aperture radar. This is an active sensor, as you can see here. It transmits its own energy source. And this is really important because it means it can detect flooding at nighttime, through cloud, through weather. So there's lots of benefits to using SAR sensors on satellites for flood detection. And the floodwaters themselves, I'll show you one. They appear dark. Okay, so this is SAR over here. So these dark regions, those are floodwaters. These images were taken last year during the Pakistan flooding event. This event affected 30% of the country was flooded. I think 30 million people were displaced. Huge flood. This is about, I should have put some sort of scale on it, but it's about a third of the country that I'm showing. So this one on the left is more like a photograph. So this is an optical satellite image. So you can see all the waters coming down, all the floodwaters. And then this can be processed to kind of make the water stand out. So this one is actually processed from this optical image, and then the one on the right is the SAR. So it does a very good job. It does as good a job as an optical image in many cases. It doesn't do as well in urban areas where there are buildings close together because of the resolution of the image and because of other issues. And it's not so good where there's dense forest canopy. It's hard to detect flooding using SAR under forest cover. So it's good, but not good everywhere in every situation. And also at the moment, this Sentinel sensor is one of a pair. So there are two of these usually orbiting the Earth. And at the moment, one of them has malfunctioned. So we used to get images every 2 or 3 days in the UK from the Sentinels. So now it's every 6 days, but they are going to be replacing it later this year, hopefully. Okay, so what do I do with this data? So I use the satellite data. So on the left, this is Bangladesh again. So this is the Brahmaputra River. These red lines are just 4 districts that we were looking at. And the orange is I don't know why I did orange, is the flooding from SAR. So this is the observed flooding extent. And we can compare this against the map on the right is the forecast flood map. So we would use the satellite data to compare against the forecast flood map to see where the model was getting it right and where it needed to be improved. So this is the same flood event. I've just zoomed in now on one of or 2 of the districts. So this is Kurigram in the north. And this map shows, it's a verification map. So it's telling you the areas that are silver were correctly predicted by the model, by the forecast flood maps. So you can see where you were getting it right. Blue areas show under prediction, and then the red areas, blue is over prediction, and then the red shows under prediction. So you'll be able to see regions where your model wasn't performing as well as it should be. And then the shading can be linked to a quantitative measure of how well it's matching the forecast, or how well the forecast is matching the observations. Okay, I hope I've spoken for long, almost. Okay, so just to summarize, I've talked about the types of flooding that we typically experience in the UK, and how our climate has warmed, and the impacts of flooding in the UK, in particular in the west and the north, more frequent and intense flooding events. I've talked about 2022 and the records that were broken in terms of heat and drought, and also the globe as a whole and the changes that we've seen. I've talked about disaster risk reduction schemes, and in particular forecast-based financing, which uses information from flood forecasting systems to link together with impacts from flooding. And I've talked about how we can detect flooding using satellites, and using this data we can use it to actually improve the forecast flood maps, which is a very important part of model development. I'm happy to take questions. If you want to read more, there's references here, and my work on the flood map evaluation, comparing against satellite data. You can scan these QR codes if you'd like to read more, or I'm happy to take questions from you as well. Thank you very much for listening. Yes.
Was the flooding event in Cornwall similar to the Lynmouth one, or was it something entirely different?
Did Lynmouth happen in the summer? I think it did. Yeah, more than likely, yes. I don't know the meteorological situation of Lynmouth, but if it was very localized flooding, which Lynmouth was during the summertime, more than likely it was caused by showers. But I would assume so. Boscastle, yeah.
Where the cloud just stopped for a while.
Mm-hmm. Yeah.
How much of this sophisticated forecasting was working in Pakistan?
Good question.
And was it in any way able to measure the sheer extent of it? I mean, the whole of Sindh practically. So that warning could have been given to people to actually get out before it happened.
It did predict I looked at this in quite a lot of detail. It did predict the event. The GLOFASS system did predict the event quite well, and it had about a 2-week, gave about a 2-week warning, or a 2-week lead time of something of a high flood event was going to happen. But probably, I don't know what happened in terms of warnings locally, or whether that information was then used to communicate that risk locally.
Did it measure the sheer extent of it? Because that was one awful part of it. These people isolated in little pockets.
Yeah, I think the majority of the river, it's the Chenab, it's the Indus Basin, it's the Chenab River. The majority was predicted to flood. One of the issues with the system in Pakistan is actually the dams, and the rivers in Pakistan are very much controlled by dam operations. Just when they decide to release water, or divert water, and that at the moment those sorts of dam releases aren't accounted for in this global model. So that's something that they're hoping, well, they're working on, they want to improve. Yeah.
I might say, I think the problem is that forecasting is now so good in all parts of the world that the reaction of local authorities, we see the same here, let's be honest about it, the reaction of local authorities is limited to money. And they don't want, you can imagine, Pakistani authorities want to move 30 million people. The sheer cost of doing that, where are they going to put those?
Yeah.
Where are they going to put this? And so you end up with disaster relief rather than relief beforehand
Yeah.
in most of these situations. And we see it, the same happen here. Don't we? We get flooding, you know, the forecasting system here is now absolutely very good indeed. But then, you know, it happens and there's not enough protection put in. You see it in Cirencester, for example. They haven't spent enough money on protecting Cirencester, as a particular example.
I was wondering about the event in Germany where they had a lot of flooding. Was there prediction of that? Presumably not the scale that hit them, and they couldn't do much to stop it.
Yeah, that's been a big, that's come up a lot since that happened, and it was really well forecast. And again, it was that communication or acting on, it's taking the action based on the forecast. And the problem now is what we're seeing is these events happening that are kind of unimaginable. Like they're so extreme, it can be hard for authorities to take it seriously.
I keep thinking that if an event like that happened anywhere up in the Church catchment, then it's going to come through Cirencester, or over Cirencester probably. And where would we go to get predictions of that? Presumably we wouldn't know until an hour or two before that cloud was coming our way.
As in for a summer event, like the extreme events. Yeah. I think that, predicting the convective events is very difficult, and it's still, work in progress or research in progress.
You mentioned that the flooding was very localized.
Yeah.
Is that another way of saying that that particular village hadn't had a big flood for many years, and therefore, although you might predict big floods could happen, predicting what would happen in that village is a very low probability. Is that right? So
yes.
So there's no way you could justify, for example, building large flood relief channels like unoccupied areas near rivers that could flood easily. But if it's going to be so rare, less than once in 100 years or whatever, there's no way you could justify it to yourself. But in a sense, that's what you would need to do.
Now, in Helen's part, we lived in Colorado through the last events. And after the event, it was amazing the amount of work council did on the ditches and streams clearing the land, which could have prevented some of the damage. It's all down to cost. That tends to happen with most incidences that action is taken afterwards, be it fire, flood, whatever.
Yeah.
I'd like to ask you a bit more about your own research, and you showed us where you were comparing kind of before and after, or a prediction and what really happened.
Yeah.
I can see how you can break it up into little squares or something and count how many match and how many don't match, and that's more or less what you showed us with the colours. Can you tell us a bit more? I mean, have you been able to find things like we did badly where there were planes, or we did badly where such and such, or we did particularly well when we had such and such a type of data, or anything like that?
Yeah. So I've looked at UK flooding. So the first piece of work I did was on actually the flooding in the Wye Valley following Storm Dennis, so in Hereford. So I was looking at Hereford, kind of more of an urban area, and then a section of the Wye through a rural area, and then part of the Lug in a more rural area. And generally speaking, we're better at predicting, or for that event, in the rural areas. I think the urban areas are a lot more complex in terms of the embankments that are built up, so man-made features or things like bridges. So the more details that are added, they kind of increase the complexity of the actual flood mapping process. So the hydrodynamic modeling, which and I think the difficulty with that is when you go overseas to somewhere like Bangladesh or Pakistan, is actually knowing where that infrastructure is. So embankments, details of that kind of detailed surface information is kind of quite, that's one of the main limiters of the accuracy of the actual flood maps themselves.
I have a couple of questions from the Zoom. John Hill asks, a question for Helen. Will your work enable the Environment Agency to revise their flood zone classification, the 1, 2, 3 levels that they have? Does your data feed into reviewing those?
Yeah, to the EA flood maps. Not directly. I don't see why it couldn't. I don't know if they use any satellite data, I don't actually know how they produce their flood maps themselves, and whether they've used any.
There's an opportunity there.
Yeah, whether there's any satellite data used for them. Yeah.
The other question is, what is the current frequency, brackets return period, of a flood level classified as in the 1 in 100 years that they used to use in 1970, say? So, I mean, presumably floods are becoming more often, where they used to talk about something being a 100-year risk. Now, presumably it's a 2-year risk.
Yeah, that's true. I've not looked at UK flooding, but Bangladesh, and I've looked at the Amazon return period changes, and definitely you're seeing kind of the extreme end of the return period thresholds that we've seen in the past occurring every other year. Just looking at the observations for, that was for, well, Manaus in the Amazon and for the Jamuna River in Bangladesh. So yes, factoring in climate change into flood frequency kind of estimation. It's quite another big area of research. Yeah.
Under climate change, are we expecting the overall rainfall in the UK to increase or decrease, even if we're going to have more extreme events?
That's a good question. Across the whole year or in a particular season?
However you want to tackle it, really.
I think in the summer we'll see overall, this is my opinion though, I don't have any stats. I think in the summer we'll see overall less rainfall, particularly in the southeast. And then generally in the winter months, I think we're likely to see more rainfall, particularly in the west and the northwest.
Okay,
is that a good way of? Yeah.
Why is it planet warming up? I'm traditional, I've always been told it's man-made and I've always believed that and largely still do.
Yeah.
But I'm running into more and more informed opinions, people who I respect, who don't believe that. I'm really interested in your opinion because you're a lot closer to it than I am.
greenhouse gas emissions are still the main cause and contributor to climate change. So increases in CO2 and methane are the main greenhouse gases that are contributing to climate change. Yeah.
Well, now we hear that the ozone layer is closing up. Yeah. I was going to ask, you mentioned El Nino. I can't remember the name of the new one we're in, but it's actually warm.
Yeah, La Nina. Yeah.
What's the prediction there? Is that going to increase the rate of warming?
Yeah, I don't know for definite, but I think I read that 2023 is predicted to be, globally warmer, because of if it is a El Nino year. I'm not sure that it is. I don't know. But if it was, then you would generally expect the globe to be warmer during that La Nina event. Yeah.
I could imagine a simulation for each of the big rivers in England, where you would work out how much would go through a bridge, if that's the issue, and that kind of thing. Is that what actually is done?
Yes. Yeah, that's what we would call hydrodynamic modeling. So you'd have a very detailed kind of model of your town, with, you can like add a bridge in, so you can add those that infrastructure in. But if you were going to try and do that on a UK scale, it becomes kind of very would take a long time to run on a computer, say. So you could do a lot of detail in a small place, or less detail on a larger area, and depending on how quickly you needed the information, because that's why the global models are simplifications of reality, I guess, because we need them to be able to run in time before the event happens. Does that make sense?
Looking at the risk of flooding and mitigation on a more local level, developers that decide they want to build a big housing estate, be it Cirencester, be it in Swindon, etc., are they compelled to come up with flood risk models and any mitigation have to take place, anything like that?
Don't know what the rules are. I know they're still building on floodplains, which I don't agree with. But I don't know if they're enforced to put in any mitigation. No.
The answer is yes, they do. Whether that is up-to-date information that they are forced to use, for example, whether it's reasonable predictions for 30 years' time, is another matter. Sorry, it's me again. Presumably, one of the issues with the radar is that it tells you where there is water. It doesn't tell you how deep it is. For humans, how deep it is quite important. But can you then marry up the radar information with topographical information from radar when it's dry? And estimate total volumes then?
You can, yes.
Okay, so that's what's done, is it?
Yeah, that can be done. It's obviously more accurate the more accurate the surface data is, or the land data. The topographic data without the flooding, if that's detailed like we have in England, that would be more accurate than elsewhere in other countries, because the topographic data tends to be very old or kind of can be decades old, and then things may have changed.
They can't get accurate topographic information from satellites.
I guess they can. You can use that INSAR. I don't know about the actual, probably not the high enough kind of spatial resolution, not as high as what we were talking about today about LiDAR data. I think you had a talk on LiDAR, which would be 1 meter resolution. It probably wouldn't be a fine enough scale to marry up accurately enough, I guess.
You're talking about huge amounts of information. You do have it.
Yeah.
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 Okay, thank you.
Sorry, coming again, does the satellite data cover the entire globe more or less uniformly, or is it very political? Is it, so it's a European satellite, so
Yeah.
it covers Europe carefully and say the Sahara not very carefully, or how does it work?
There is slightly more coverage in mid-latitudes. I know that much, but it does scan the whole world. Or the lands, well, the whole, or the Lancer, that satellite, or the Sentinel satellite scans all land surfaces, I think.
Can its orbit be changed?
Yes, so I don't know if they use the same satellite or if they use another one, but they can also trigger like an emergency scan. So for that flooding event in Bangladesh in 2020, I was really excited because there was actually a lot more scans. It was almost every day. So it was really, the Copernicus Emergency Management Service. So it's the EU run satellite or provider. So yeah, if there's a severe flooding event, like probably, I don't know, there's flooding in California at the moment, so the chances are that would have perhaps triggered an emergency scan, or when there were floods in Australia, there were definitely extra. So you can get extras, and there's also a lot of commercial satellites. Unfortunately, it's not always easy to get hold of that data, and they can be very precise in where they scan, and they can get there quite quickly, and also have a higher frequency, almost daily. But I guess because that data is so valuable, yeah, it would be good to have more research on that sort of data, I think, using that data.
So on a frivolous note, can you please predict some snow for my skiing holiday in March?
It'll be better than it is at the moment.
I mean, is it going to stay warm?
I haven't even looked at the long term,
so it's not
seasonal
related.
forecast.
I mean,
Yeah.
okay.
There's been some apparently very recently. It's a bit better than it was. Good questions.
Well, thank you very much, Helen.
Thank
Very good
you.
talk.
Thank you.